Question number 18. The de Broglie wavelength of a neutron traveling with a velocity v is lambda. If the kinetic energy of this neutron is increased 4 times, the new de Broglie wavelength would be. Right, there are two situations. The before situation where the kinetic energy is not increased, and after the situation. Let's say before situation, before the kinetic energy is increased, and then after the kinetic energy is increased. Now here the kinetic energy is E equals to half mv squared. Now after kinetic energy has been increased, so it will be 4 times E equals half, still the same m because it's the same neutron, but the speed of the neutron is now different. Let's say it's u squared. So this is our first equation, this is our second equation. So we can construct a relationship between this v value and the u value. Let's say 1 divided by 2. So E divided by 4E will be equals to half mv squared over half mu squared. Now E is cancelled off, half m is also cancelled off. U squared will be equals to 4v squared. If we take the square root of both sides, u will be equals to 2v. Now which means when the kinetic energy is increased 4 times, that means the velocity of the neutron has increased 2 times. Now we have the relationship between the velocities. Let's apply these values to the de Broglie equation. Now the de Broglie wavelength is equal to h over mv, the Planck's constant divided by the momentum. So initially they say it's lambda, h over mv. For the after situation, lambda equals, let's say it's lambda dash, h over mu. Now this is our third equation, this is our fourth equation. Let's divide the third equation by the fourth one. So we will get lambda divided by lambda dash equals h over mv divided by h over mu. So lambda over lambda dash will be equals to, here h will be cancelled off, m will be cancelled off. So it will be equal to u over v. Now instead of u, we can put 2v here. So lambda over lambda dash will be 2v over v. So we get the v cancelled off. Therefore lambda dash will be lambda divided by 2, which means the new de Broglie wavelength will be the half of the previous de Broglie wavelength. So the answer for this question will be the first one. Okay, let's move on to the next question.